Welcome back. In the last lesson, we did a budget estimate. In that budget estimate, we used a parameter to estimate software costs. In this lesson, we are going to look at a formal method to estimate software costs. This method is called a use case point method. Use case point method includes 7 steps. The first step is develop use case diagram and use cases, calculate unadjusted actor weight, calculate unadjusted use case weight. The fourth step is estimate technical and environmental complexity. The fifth step is calculate use case points. The sixth step is calculate effort, and then finally calculate total cost of the software. The first step is develop use case diagram and use cases. I'm going to explain the method by using an example. Let's say our company is interested in developing an online shopping system. This system includes a customer. The customer views products, they purchase products, they manage their customer information, and after they have bought the product, they may write a review. This system interacts with a payment processing system. The payment processing system verifies the credit card that the customer uses to make the payment. The system also includes a warehouse clerk whose role is to fulfill orders. The system also includes a marketing administrator who manages products that are sold and report on product sales. The system also includes a warehouse manager who reports on inventory and manages the inventory. The second step is to calculate the unadjusted actor weight. We classify the actors in the system as simple, average, and complex. We have one simple actor, the payment processing system. In this system, we don't have any average actors, but we have 4 complex actors: the warehouse clerk, the warehouse manager, the marketing administrator, and the online customer. So we have one simple actor and 4 complex actors. So how do we assess whether an actor is a simple, average, or a complex actor? We classify actors in this way. A simple actor is an external system that interacts with the system using a well-defined API. A simple actor has a weight of 1. We classify an actor as an average actor if it is an external system that interacts with the system using a standard communication protocol like TCP/IP or HTTP. An average actor has a weight of 2. We classify a complex actor as any human actor that uses a graphical user interface to interact with the system. A complex actor has a weight of 3. So for our system, we have one simple actor. We don't have any average complexity actors, but we have 4 complex actors. So our unadjusted actor weight is 13. In the next step, we calculate the unadjusted use case weight. So again, we classify use cases into simple, average, and complex. In our system, there are 2 simple use cases: view products and report inventory. We have 3 average complexity use cases: manage customer information, create product review, and report product sales. We have 4 complex use cases: purchase products, fulfill order, manage inventory, and manage products. We use this method to classify use cases as being simple, average, and complex. If a use case can be executed in 1 to 3 transactions, that is, if a use case can be executed in 1 to 3 steps, we classify that use case as a simple use case and it has a weight of 5. If a use case can be executed in 4 to 7 transactions, that is 4 to 7 steps, then we classify that use case as an average use case and it has a weight of 10. However, if a use case requires 8 or more transactions, that is 8 or more steps, then we classify that use case as a complex use case, and a complex use case has a weight of 15. So in our system, we have 2 simple use cases, we have 3 average complexity use cases, and we have 4 complex use cases. So for our system, our unadjusted use case weight is 100. In the next lesson, we will going to continue with this example. Thank you. Welcome back. We will continue with estimating the software costs for the proposed online shopping system. The next 2 steps are calculating the technical and environmental complexity factor. These 2 steps require us to identify relevant subfactors and identify their relative importance, and then the development team assigns value to each of the subfactors based on the complexity of the project. They will assign a value of 0 to a subfactor if the subfactor is irrelevant. They will assign a value of 3 if the subfactor has average influence, and they will assign a value of 5 if a factor has a very strong influence. So let's start with the technical complexity factor. Technical complexity is estimated based on 13 factors. These 13 factors are assigned relative weights. So the system assigns them relative weights, but then the development team assigns a value to each of these 13 factors based on the system that is being proposed. So for example, we are talking about an online shopping system here. So the development team may say that the security features are very important and assign a value of 5 to security features. So we assign a value to each of the 13 factors. Each of the 13 factors has a weight. Then we multiply the weight with the assigned value and then calculate the total factor, that is the total technical factor. From this number, we can calculate the technical complexity factor. Technical complexity factor is calculated as 0.6 plus technical factor divided by 100, that is 0.6 plus total technical factor divided by 100. The total technical factor is 42 in our case, so the technical complexity factor is 0.6 plus 42 divided by 100, which is 1.02. The next step is to calculate the environmental complexity factor. The environmental complexity factor is calculated based on 8 subfactors. Again, these 8 subfactors have a relative weight, and these are the weights assigned for this method of calculating software costs. So these weights don't change based on the system being proposed. However, the system being proposed determines the assigned value. That is, the development team assigns values to each of these 8 factors. So for example, the development team may say that they have a very strong analyst and assign a value of 5 to the lead analyst factor. So our total environmental factor is 10.5. Now we can calculate the environmental complexity factor. The environmental complexity factor is calculated as 1.4 plus minus 0.03 times total environmental factor. So our environmental complexity factor is 1.4 plus minus 0.03 times 10.5. So for the system being proposed, the environmental complexity factor is 1.085. In the next 3 steps, we will calculate the use case point, the effort, and the cost. The use case point is calculated as unadjusted use case weight plus unadjusted actor weight multiplied by technical complexity factor and environmental complexity factor. We have calculated these numbers as 100, 13, 1.02 and 1.085. So, the use case point for the proposed online system is 125.06. Now, we can calculate the effort to develop the proposed online system. Effort is equal to use case points times productivity factor. Productivity factor is an estimate of how long does a developer take to develop one use case point. This number can be based on the data collected by the company, or it can come from an industry standard. This number usually varies between 15 to 30. So, let's say in our context we have data, or we use industry benchmarks to determine that it takes a developer 28 hours to develop one use case point. So, in our case, our proposed system is about 3,500 hours of effort. Now, we can calculate the total cost of developing the online shopping system based on the average cost of labor. So, if our average cost of labor is $50 per hour, the total cost of developing the online shopping system is $168,500. So, the cost of software, the cost of developing the software for the online shopping system is $168,500. Thank you. Welcome back. In this lesson, we are going to focus on benefits of IT systems with special emphasis on intangible benefits of IT systems. In decision theory, decisions can be operational, tactical, and strategic. Likewise, IT systems can have operational, tactical, or strategic benefits. When IT systems have operational benefits, such benefits are very tangible in nature. However, when IT systems have strategic benefits, these benefits are very intangible in nature. Using the CMEX's online dynamic synchronization system, we can illustrate the different types of benefits. In the CMEX's dynamic synchronization system, the operational and very tangible benefits are reduced number of trucks and fuel savings. So, the proposed dynamic synchronization system allowed CMEX to meet customer demand using fewer number of trucks while saving fuel. So, these are very tangible benefits. However, the dynamic synchronization system also improve the brand reputation of CMEX. The system allowed CMEX to give customers a 20-minute delivery window. This 20-minute delivery window allowed CMEX to differentiate from competitors and charge premium prices. So, in some sense, though the system had operational benefits that were very tangible, the system also had very strong intangible benefits that improve the strategic positioning and the value of the firm. So, in some sense, the proposed dynamic synchronization system increase the value of the firm. So, let us look at what this means. We can evaluate the worth of a firm based on the market value of the firm, and this worth of the firm includes the value of its balance sheet assets plus sort of intangible and value measured beyond the assets of the firm. So, to take an example from a local company, on December 31st, 2010, 3M had a market value of $70 billion. Out of these $70 billion, only about $30 billion is based on balance sheet value of its assets. So, on the balance sheet of 3M, the total value of its balance sheet assets was about $30 billion. What that means is that out of the $70 billion, $40 billion worth of the company is beyond its balance sheet assets. That is, the intangible value of 3M is $40 billion. That is, the firm's worth is mostly driven by the intangible assets of the firm. So, let us look at what is an intangible assets. Lev defines intangible assets in this way. Assets are claims to future benefits such as rent generated by commercial property, interest payments derived from a bond, and cash flows from a production facility. An intangible asset is a claim to future benefits that does not have a physical or financial embodiment. A patent, a brand, a unique organizational structure, for example, an internet-based supply chain that generate cost savings, are intangible assets. So, to summarize, physical assets or tangible assets have a physical embodiment, plant or cash. However, intangible assets do not have a physical embodiment. So, the question comes, do IT investments create intangible value? Do IT investments create intangible value? As we saw in the CMEX example, IT investments can create tangible value by reducing the number of trucks required, by saving fuel. But the example also showed that the system can create intangible value by improving the brand and the differentiation capability of the firm. So, in a very interesting study, Saunders and Brynjolfsson examined the relationship between assets of the firm and its market value. Their objective was to evaluate if IT investments create intangible value for the firm. So, in this study, they relate different assets of the firm to its market value. They considered ordinary assets like the plant, property, and equipment of the company. Other assets include cash, inventory. So, ordinary assets and other assets are physical assets. They also considered intangible assets like R&D and brand, and they also considered information technology assets. They assessed information technology assets in three different ways: hardware only, hardware and software, or all, that is hardware, software, consulting, training, everything included. And they related assets with the market value of the company. They found that each dollar of hardware is associated with about $9 of market value of the firm. So, in other words, a dollar of hardware assets is associated with an additional $8 of intangible value. When they thought of IT as hardware and software, a dollar of hardware and software is correlated with about $6 of market value. That means a dollar of hardware and software creates $5 of intangible value. Finally, when they considered everything IT, so hardware, software, training, consulting, again a dollar of IT creates about $1.15 of intangible value. So, that means on average IT investments create intangible value. However, they dug deeper to see if all firms derive intangible value from their IT investments. To do that, they classified different companies into grade A, grade B, grade C, grade D, and grade F. They assessed the information technology capabilities of firms based on HR capability, management capability, internal communication capability, communication with suppliers, and internet capability. They classified firms in the top 5 percentile as grade A firms. They classified firms in the 85th to 95th percentile as grade B firms. They considered grade C firms as the average firms, so firms that are between 15 and 85th percentile. They considered firms in the 5 to 15th percentile as grade D firms, and they considered the bottom 5 percentile as grade F firms. In academia, we don't have grade E, so there was no grade E. Okay? And then they ran the analysis again. This time they scaled based on employment or IT capital. They found that compared to the average C firm, for the A grade firm, each employee was associated with about 120,000 of higher intangible value compared to the average, that is grade C firm, whereas a grade F firm, for a grade F firm, each employee was associated with about 172,000 of less intangible value compared to the grade C firm. Similarly, when they scaled based on IT capital, for a grade A firm, each dollar of IT capital was related with $15 of market value, whereas for a grade F firm, each dollar of IT capital was associated with $5 less compared to the grade C firm. What this analysis illustrates is that IT investments create intangible value for the firm, but this intangible value depends on IT capabilities of the firm. If a firm has A-level IT capabilities, like if a firm has a CMEX type system, then it creates significant intangible value for the firm. But if a firm is a D firm or an F type firm, then IT investments decrease intangible value for the firm. So bottom line, IT investments can create tangible as well as intangible value, and this intangible value that IT investments create is reflected in the market value of the firm. Thank you.